In this video, we're going to look at something called an amine, which features a nitrogen. So, amines are nitrogen-containing organic compounds derived from ammonia. So there is ammonia right there. It's a nitrogen with 3 hydrogens. So for us to create a more complex amine, what we're going to do is we're going to take off one of these hydrogens and we're going to switch it with some kind of carbon chain. So here we go. So we've created a methylamine because we've added a methyl group to the amine. And that is also the way you're going to name these too. And this is what's called a phenol group. So this would be a phenylamine. Amines have unpleasant odors. Those with low boiling points smell like ammonia. And those ones that are liquids at room temperature have fishy aromas. So anyway, they have a pungent smell. So an alkyl group or aryl group can be represented by a capital R when drawing a chemical structure. This is referred to as the R group. So when we're talking about a primary amine, we're talking about a nitrogen that has one of these chains attached to it. When we're talking about a secondary amine, it's got 2 carbon chains attached. They could be the same. They don't necessarily need to be. And a tertiary or third degree has 3 of these carbon chains attached. So to name these ones, we're just going to be using the suffix amine at the end. So here's some examples. So in the first one, right here, we've got a methyl group attached. So this becomes a methylamine. In the next one, we've got an ethyl group attached, ethylamine. And in our third example, we have a propyl group, we have a propylamine. So if we have 2 identical ones, there's actually a couple of different ways to do this. You can use a di to represent the fact that there are 2 ethyl groups, so diethylamine. Or even in our next example, it's going to be a triethylamine. So dis and tris when we've got the same group repeated. Well, sometimes you've got different groups, and we're after alphabetical order here. So here's a few. In this first example, we've got an ethyl and a methyl group. Ethyl coming before methyl alphabetically. Gives us an ethylethylamine. And in our next one here, we've got an ethyl and 2 propyls. So we've got an ethyl dipropylamine. And these ones are a little more complicated here. A methylphenylamine. And lastly, a methyl diphenylamine. So some properties now of these. Shorter chain amines are soluble in water as long as the lone pair of electrons on the nitrogen atom allows them to form hydrogen bonds with water molecules. So the longer the amine chains are, they're going to be sparingly soluble. So you can see the blue dotted lines here are representing the hydrogen bonds. And you can see these molecules have dipoles. So we are talking about a polar molecule. That's why they're able to dissolve in water. In the aqueous solution, amine molecules are able to accept an H+ from the water molecule, resulting in an alkaline solution due to the remaining OH. So comparing some boiling points here, so it's useful to compare the boiling points of methylamine with that of ethane because both molecules have the same number of electrons and have roughly the same shape. So we've got some alkanes here and we've got some amines here. And you'll notice that our alkane chain, as it increases in length, its boiling point increases, and same with our amines. And it has to do with that hydrogen bonding idea. So secondary amines also form hydrogen bonds, but as nitrogen atoms in the middle of the hydrocarbon chain, the strength of the dipole is slightly less. This decreases the strength of the dipole attraction. This decreases here. So now we've got some... you can see the different degrees of the amines here, and you can see our boiling point is actually going down. Again, there's just less attractive forces between molecules, and so your boiling point decreases. So reactions here. We're going to look at some synthesizing. So how do we actually make these ones? Well, what we're going to do is we're going to react an alkyl halide, and I'll show you what that is right here. If you don't remember that from previous courses, all it is it's one of the halogens attached to our carbon chain. So we've got the iodine here, iodoethane it's called. And what we're going to do is we're going to react that with ammonia. So we're simply going to have some switching around here. In fact, all that's really going to happen is, and we can pick any hydrogen on our ammonia, we're going to sort of switch those 2 things around. So that stuff is now right there. and this other stuff here has taken its place. And so what we end up with is we've got a primary amine. We've got one carbon group attached to our nitrogen. So we can take that exact same primary amine and combine it with the exact same alkyl halide that we started with. So there's the same alkyl halide, and there's the product we just formed in the last reaction. And all that's going to happen is, again, we're going to have a little switching around, a little substitution reaction. And you'll notice that we actually have formed a secondary amine. Now, listed on here, and it's probably a good time to point this out, is we have this kind of stranger name. Normally, we could have just called this diethylamine. That would have been acceptable, but this is the IUPAC name. So it's saying that it's an ethanamine, which kind of refers to this stuff here, if you will. It's got an ethyl group attached. And then this N just says that one of these ethyl groups is repeated. And then to sort of finish this off, you can take that same sort of, or same product and react it now with the secondary one we just formed, and we can form that tertiary. And again, we've got that sort of strange name here. So the ethylamine part, I would tell you, is represented by that, and then we've got a couple of N's and a diethyl representing that stuff. To me, that's a more complicated name. Triethylamine works so well. I think that's the one that I would stick with.